Hello everyone. That's a very easy question, but a very important one. Okay, so in this question you have to find the sign of op-amp to ensure negative feedback. Okay, so what you need to do whenever they ask to find the sign of op-amp for negative feedback, I will just tell you one simple method. Just get the output of op-amp. Here we have the output of op-amp, right? V naught dash. Now just increase V naught dash. There will be something happening in the circuit. Now if you increase the output and your eventually your output is decreasing, your V naught dash is decreasing. You increase the output, but something happened in the circuit and eventually your output is decreasing, then it's in negative feedback. Okay, if you increase your output, something happens in the circuit and your output is again increasing, so this would be an unstable system and it would be in positive feedback. This would be a stable system and this would be in negative feedback. Okay, so let us try it in this circuit. So look, here we have V in. So just short circuit this, because uh, for finding the sign of op amp, we can simply neglect all the independence of this. Okay, so this would be replaced by simply a resistor R out, because VGS value will be 0, so GM VGS would also be 0, so this can be replaced with only an R out value. Okay, now you are increasing V naught. V naught dash you are increasing, then your gate voltage for NMOS is increasing, right? Gate voltage for NMOS is increasing, so your VGS value is also increasing. Now your VGS value is increasing, that means your ID is increasing, the current through this MOSFET is increasing, so your ID is increasing. So if ID is increasing, so this drop across this resistor, R naught resistor, is increasing, right? Now this drop would go here, VR would go here. Now you want your output to be decreased, right? If your V out, first I assumed V out to increase. Now I want my output to decrease. So if I make this one negative and this one positive, so what is our V naught dash? It is A V positive minus V negative. If I make this one to go up, then this would decrease, right? If my V in is increasing, my V negative is increasing, my V output dash would decrease, right? So what I am saying here is my drop across R naught resistance is increasing. Now if I make this one negative, my V output would decrease and this op amp would go in negative feedback, right? I will explain it once more. देखो क्या किया, सबसे पहले इसको आर नॉट से रिप्लेस किया, ठीक है? अपन ने इसका आउटपुट बढ़ाया, ये बढ़ाया तो यहाँ पे ड्रॉप इंक्रीज हुआ, ये ड्रॉप इसी में जा रहा है, इस वाले टर्मिनल में जा रहा है, तो अपन ने देखा कि बढ़ा हुआ ड्रॉप इसमें से जा रहा है, तो अगर मैं इसको नेगेटिव बना देता हूँ तो फिर ये मेरे आउटपुट को इवेंचुअली कम कर देगा। तो मैंने बढ़ाया आउटपुट और इवेंचुअली कम हो गया, इसका मतलब ये नेगेटिव फीडबैक में, इसका मतलब ये वाला साइन पॉजिटिव होना चाहिए और ये वाला नेगेटिव होना चाहिए। समझ गए? ये इंपॉर्टेंट है, बहुत बार पूछा जाता है, ठीक है, और काफी लोगों को पता नहीं होता, तो ये ध्यान रखें। ठीक है, अब आपको इम्पिडेंस फाइंड करना है, तो ये सब तो मैं बता चुका हूँ, फिर भी एक बार और कर लेते हैं इसको, ठीक है? हाँ, तो देखो इम्पिडेंस फाइंड करने के लिए क्या होगा इसमें, देखो वही वी इन को वापस शॉर्ट करेंगी, तो ये तो एक रजिस्टर से रिप्लेस हो जाएगा पूरा, इसको आर नोट बोल दो, ठीक है? ठीक है, इसको आर नोट वन बोल देते हैं, इसको एम वन एम टू बोल देते हैं, इसको एम वन बोल देते हैं, तो इसको आर नोट वन से रिप्लेस कर दिया। यहाँ पे कोई करंट जानी नहीं है, ठीक है, तो ये ऐसे ही गया, यहाँ पे कोई करंट जानी नहीं है, तो इस ओपैम का तो कोई काम ही नहीं है, इसका तो कोई काम ही नहीं है, आउटपुट रेजिस्टेंस बताने में कोई काम नहीं है, क्योंकि यहाँ पे तो कोई करंट जाएगी नहीं। तो बेसिकली आपका सर्किट अब क्या बचा है, आपका योर सर्किट वुड लुक समथिंग लाइक this NMOS, this R naught resistance, here you have some voltage whatever you call it, and here you have V output, and you need to see R output from here. Now this circuit I have already explained, you can what you need to do, you will just short circuit this, because this will have some DC voltage there, so you can DC voltage or any voltage, so you can simply short circuit this one, and now you can simply find the R output value, and that value is equals to, that value is approximately equals to Gm R naught 2 into R naught 1. I don't remember the exact expression, it is something like this as far as I remember, 1 plus Gm R naught 2 into R naught 1, not the exact expression I remember, this is the approximation. Okay, so we simply remember this formula many times, because this is used many times, but you can derive it as well. you will get something like this. By taking approximation, you can get up to this formula. Okay, so this is not right, that I know. So approximately this is right. Okay, so you can derive it by your own. Okay. Look, just now I thought about this circuit, and there is one error I can find. Like, I don't think I can make this one as short circuited, right? Like, why? Because mm, for finding the R output, what I will do, I will apply one V output here and I output here. So my R output would be V output upon I output, right? Now this I output is flowing through this resistor and would give me I output into R output voltage here. I output into R output 1 voltage here. I can short circuit this one, right? I can short circuit this one VB voltage, this DC voltage I can short circuit. But here I am having I output into R output 1 voltage, right? Now here what I will have? Here I will have gain A into I output into R output 1 minus sign would be there. So V positive is 0, so this would be my value here. Okay, so minus A into I output into R output 1. Now this is an AC quantity. I can't really make this whole quantity, make this voltage to be 0. I can't really make this to be 0. Why? Because this is an AC quantity. So now you have to apply the equations and get to the final answer. And in the final answer, you will have A there as well, like this gain as well. So that's how you reach the final answer. Now I will solve it in rough once, and then we'll tell you the answer. So let me try it once. Yeah, so I just solved this circuit in rough notebook. So it goes something like this. First I drew the uh, RE model. Here we have GM VGS current. Here we have 1 upon GM resistance. Here I have minus A into I output R01. Here I have R01 here, and here I have V output, I output, and this is R02, right? So this I output will be flowing through here as well, and the current flowing through this resistance, this resistance would be I output minus GM VGS, right? Okay, so what you can write? You can write I V output equals to R02 into I output minus GM VGS plus I output into R01, right? So now what you can write? I output R01 plus R02 minus GM R02 VGS. Okay, now your VS value is this VS value is I naught into R naught 1, and this VG value is this value. So now you can write V naught equals to I naught into R naught 1 plus R naught 2 minus GM R naught 2. Your VG value is minus A I output R naught 1 minus VS value is I naught R naught 1, right? So your I naught would be R naught 1 plus R naught 2 plus A into GM R naught 1 R naught 2 plus GM R naught 2 R naught 1. So eventually this is your output voltage, R naught 1 plus R naught 2 plus A into GM R naught 1 R naught 2 plus GM R naught 1 R naught 2. Okay, so that's the final answer. So first we did like we just short circuited this one, that was wrong. Okay, so your final output can be assumed as this expression only. So the previous gain into op-amp gain, that you can tell. Okay, so it was a good question. I just realized in between the video only like that I can't really short circuit this one. So I guess this is the final answer. Okay, thank you. And also if you have some questions or some suggestions, then that you can write in the comment section as well. Like if there is some mistake or anything like that, you can comment in the chat section. Okay, thank you.